Okay, we're going to do some review with inclines, friction, everything that we've done with chapter 4 and 5 in order to review for this test. Okay, you guys are going to have another homework assignment today over inclines. Okay, because those incline problems put together everything we've done. Right minus left, friction, inclines, components, they do it all. Okay, so we're going to do another assignment today over inclines, but we're going to do some practice with them first. Are there any particular problems that you think you want to practice?
All
of them. Okay.
Like a general idea of like what the quiz would look like almost.
Okay.
Or exactly like the quiz.
All right, we're going to do one that says this. Okay, a crate weighing. A crate. Oh, I can't write today. $12.50 newtons. Slides down. A 6-meter long incline. Wow, I can't write today. That's 3 meters tall. We want to find coefficient of the crate and the incline. Okay, so we're going to say it's moving at constant speed. Moving at constant speed. We're going to solve for coefficient of friction. Okay, it's telling us that it's moving at constant speed, so what's that have to mean then? The net is 0, which will then mean right will equal left. Okay, so parallel will equal frictional force. As soon as you have this written down, I'm going to clear this off so I can have some more room to write, but I want to make sure you have it down. Okay, everybody yes? Okay. So let's say that it tells us that our incline is 6 meters long and 3 meters tall. So here's kind of our incline. We know this is 6. We know this is 3. Were we given our angle? No. So we have to find that angle in order to start solving our problems, right? Otherwise we don't have our angle for our gravity triangle. So we need to solve for this theta first. And how do we solve for that? Which ones do we have? We have the hypotenuse and we have the opposite side. Okay, so we use second sine. Opposite over hypotenuse. Okay, does everyone see how we got second sine? Why do we use the second? Yeah, when you solve for the angle, use the second function. Okay, so second sine of 3 over 6 is what? What did you say? 30 degrees. Okay, so that's then the angle of our triangle now. We know that this angle right here is 30 degrees. Okay, so now we can go ahead and draw our object here. Here's our crate. On the incline, this is 30 degrees here. So we know that when we draw our forces, our angle can be 30 degrees. And where does the 30 degrees go in this little gravity triangle? At the top. Okay, it always goes right next to the incline. All right, so let's label these forces. Tell me what this force should be labeled right here. F normal. What about this force right here? F of G, good. What about this bottom one? F parallel, and this one right here? F normal, good. All right, am I missing something here? Yeah, I'm missing my force of friction because we're solving for the coefficient of friction. That means we must have a frictional force. So I draw my force of friction up here. Okay. So we want to solve for the coefficient of friction. So you tell me how you want to start. There's many different ways you could go about solving this. You tell me what you want to do first. Find F of G. Good. F of G, what is it? Yep. We're not given a mass this time. We're given the weight. We're given F sub G. So we just know that F sub G is 15 or 1250. Okay, they told us that because it says an object that weighs 1250 newtons. So that is F sub G. So we can then plug that in down here as the hypotenuse of our triangle. Okay, so now how do you want to go about solving the rest of it? Are we going to need to find the normal force?
No.
You say no, you say they're the same. The normal force would not be the same as the gravitational force because they're not set directly opposite. This one's at an angle. We have to find this normal force. We have to find this parallel force. What's the purpose of finding our normal force? What do we need it for? What about this equation? Right? We need it for our frictional section, right? We need that to find friction, to find our coefficient. So we have to end up solving for all of these components. We have to solve for parallel, we have to solve for normal, and we'll use those to solve for the coefficient. So let's solve for parallel first. 1250 times what? Sine of 30. 1250 times sine of 30. Okay? Make sure that your calculator is in degrees, not radians.
65.
What'd you get? 625. All right, and let's find force normal. Take 1250 times cosine 30. What is it? Okay. So now let's go ahead and look at our horizontal net force here. We know it's moving at constant speed, which means that the horizontal net force should be 0. Okay? So if we do F net equals right minus left, what would our rightward force be? F parallel. Do we have any more rightward forces? Nope. What would our leftward force then be? Force of friction. Okay, so we take right minus left. F net equals right minus left. This is only for horizontal right here. Okay, and we know since it's moving at constant speed, this needs to be 0. So F parallel minus force of friction equals 0. We can move force of friction to the other side so that we can see force of friction equals force parallel. Okay, we should be able to see that just from constant speed. The reason I give you these is to just show you that the math proves that. Okay? When you see constant speed, you should be able to see that right equals left. Okay? If there's no applied force, then the parallel's got to equal the frictional force. Okay? So right has to equal left when we're moving at constant speed. So that means that our frictional force will then equal what? 625, exactly. Okay? So then we can do a substitution here for our frictional force equation, right? Does everyone see that part? Okay, so I can take mu k times the normal force equals 625. Okay, and we're solving for mu k. Do we know the normal force? Yes, because we solved for it already. Okay, the normal force is what? Yep, 1082.5. So we just divide what? Yes, divide 1082 to get UK by itself. And we should get some decimal place. 0.577. Okay. So UK equals 0.577. Okay, what happens if you get a UK that's over 3? Do you think you did something wrong? Okay, typically that coefficient of friction will be 1 or less. Typically, okay? There's been places in the past that I've messed up the numbers and it's been a little over 1, but for the most part it should be under 1. It should definitely be under 3. If it's over 2, over 3, you might want to look and make sure you divided it on the right side. Okay, you divided it correctly. Okay, so here we have a crate that weighs 400 newtons. It's pulled along a horizontal sidewalk, so is this on an incline? No. Okay, it gives us an angle because the rope that's pulling this crate is being pulled upward at an angle. So someone's dragging this box, okay? It gives us the force on the rope, and we want to find coefficient of friction. So this is not sitting on an incline. On your original quiz, quite a few of you tried to draw problems like this like they were on an incline just because it gives you an angle. That's not correct. Okay, so I'm going to show you how to draw these ones. You need to be able to interpret if it's sitting on an incline or not. Nowhere in this problem does it tell us it's on an incline, let alone it says it's on a horizontal sidewalk. Okay, that means it's just on a flat surface. Okay, can I get rid of this, or is people still writing? People are still okay, so here's the free body diagram of this system, okay? Here's our angle. This is our force on the rope right here, going at the diagonal. Here's the normal force, which goes perpendicular to the surface. Force of gravity will offset that, and force of friction is here, okay? So now we need to break down this force on the rope into components because we can't deal with it at an angle. So we can just call this F applied, or you can call it whatever you want. I'll just call them Fy and Fx, just for shorter. This would be what I would normally call F applied Y, F applied X. Does that make sense to everybody? Okay, I'm just not writing the applied part. So how do you want to go about solving for this? I'll leave it up to you. Okay, we need to eventually find a section of this frictional force. We need to find the coefficient of friction. That's our overall goal here. Okay, let's break down the triangle first. Okay, so F of Y we're going to find using what? Good, sine. So we'll take 150 times sine of 45. What'd you get? 106. Yep. Why is it the same for both of them? Exactly, because it's a 45-degree angle. So for x, we're going to use cosine 45. We're going to get the same thing because it's a 45-degree angle. All right, so we have our Fy and we have our Fx. Now what would you like to go about doing?
For this one, do we use that same equation to find the, what are we finding?
The coefficient? Mm-hmm.
Yeah.
Yep, it's still going to come from this force of friction equals UK times the normal force.
Should we just divide the 106 by 400?
Could we divide the 106 by what?
400
Why?
to find your UK.
What's the normal force?
400.
This is why. The reason that the normal force isn't just equal to the gravitational force is because we have this Fy that's contributing. So we have to take up minus down, right? We know that it's not moving at all, so F sub g has to then equal both of these up forces added together. So that's why the normal force in this case isn't just 400, because it's got to take into account this F sub y, because that's taking some of that pressure off the normal force. So to solve for the normal force, we'll take our vertical net force equation. Sorry. Okay, we'll take our vertical net force equation. So vertically, is this moving? Well, let's see. We'll just do it all right here. So we'll take up minus down for our vertical net force equation. So up we have what? F what?
Oh, normal.
F normal. What else do we have going up?
Fy.
Fy. And what do we have going down?
G.
Fg. Okay. So is it moving vertically at all? Is this system moving vertically? Okay, so this is a 0.
There's also F net equals.
F net equals, yes, sorry. Okay, so Fn plus Fy minus F sub g. So we can move Fg to the other side, and we know that Fg then equals Fn plus Fy. Okay, so normally we get to this part, and these two are the only vertical forces, so Fg equals Fn. In this case, it's not, because we have another upward force. So Fg has to equal the normal force plus the y component. Okay, does that part make sense to everybody? All right. So now we know that F sub g is 400, right? Because that's given in the problem. We want to solve for our normal force, and we just solve for F sub y to equal 106. So now we just subtract over the 106. And we know our Fn equals 294. Okay. So now we have our normal force. We're going to solve for our UK, but we don't have the value of our frictional force yet. How do we go about solving for our frictional force?
Right minus left.
Okay, right minus left. So what did our problem tell us? That it was moving at what? Constant speed, which means right has to then equal left. So that means our frictional force has to equal what on the left?
106.
Or what on the right? Yeah, f of x. Okay, so frictional force then has to equal 106. Okay, so frictional force equals 106 because they're moving at constant speed. So we can do a little substitution here. Mu k times our normal force, which we found to be 294. Equals 106. We divide by which of those? 294. Yeah, we take 294 on both sides. And we should get about 0.3 something.
0.360.
Okay.
361.
So mu k equals 0.36. We'll just round to there. 0.36.
How many do you, like, on the quiz, how many adjustment places do you want to do?
Typically about 2. Yeah. Yeah. Okay, so here we're giving 137 as our weight. We need to take that divided by 9.8 to get our mass. That will be our first step. Okay, and the only reason that we're having to do this because it's not moving at constant speed. It's moving with an acceleration, which will then take into account our net force. So we'll change our net force a little bit. Okay, so am I good to clear this screen off? Okay. So let's say that f of g we know equals 137. I'm going to take that divided by 9.8, and we get what? 14 grams. I'm sorry, kilograms. Okay. So that equals our mass. Let's go ahead and draw the free body diagram here. Have our crate. We have some force that's pulling at a 65-degree angle, and that's 50 newtons. F sub g, F sub n, and what else do we have?
Friction.
Yeah, friction, because we're solving for the coefficient, so we know there must be friction of some sort. Okay, so we've solved for our mass. Now, what else would you like to do? What should we probably do next? Yeah, exactly. Break them into components. So we'll call this Fy, Fx. Our f of y will equal 50 times what?
Sine.
Yeah, good. Sine of 65. Sine because that Fy is opposite.
45.3.
Okay. And then our Fx will take 50 times cosine of 65.
21.1.
Okay. 21.1. All right. So are we getting too far ahead, or does everyone feel like you're moving along with us okay? Okay. So now you choose. We can solve for the normal force or we can solve for the frictional force. We're going to need both of them at some point. Normal. Okay, let's solve for the normal force. Let's look at our vertical forces all together here. Okay, we have a normal force that's going up. We have a y component force that's going up, and we have gravity that's going down. Okay, so we'll write our net force vertical equation here. F net equals F normal plus what? Fy minus Fg. Okay, I need you to be pretty confident in putting this equation together. Do you feel pretty confident putting that together? Okay, so we need to think vertical first and then horizontal, or horizontal first and then vertical. Whatever you choose to do in whatever order is not a big deal. You just need to make sure that you're keeping them separate, vertical and horizontal. Okay, so is this object accelerating vertically at all? No. So this is 0. The acceleration that was given in the problem is horizontal, right? The box is moving horizontally. It's not moving up and down. That's a big stumbling block, I feel like, for a lot of you, is that you see an acceleration and you want to plug it in for both places. It's only accelerating horizontally, okay? So take a step back, think about if it's moving up and down at all. It's not, so that's 0. Okay, so that means our normal force plus Fy minus Fg equals 0. So we can move Fg to the other side, and we know our force of gravity equals our normal force plus our applied y force. All right, our force of gravity was given to us in the problem, right? We know it's 137. We're solving here for our normal force, and we just solved for our f sub y to be 45.3. So how do I get into the normal force by itself? Yeah, good. Subtract it over. So I'm going to subtract out 45.3 here, and I'm going to get my normal force to equal what? 91.7? Okay. So now we have our normal force. Now let's switch gears to horizontal. Okay, so let's look at our horizontal net force equation. All right, so our F net horizontal will equal right minus left. So our rightward forces are what? F of x. So force x minus force of F. Okay, so now we can start doing our substitutions here. Since F net is not 0, because it told us it was accelerating, we need to take our mass times our acceleration here, correct? So we're going to take our mass we solved to be 14. And our acceleration we know is 0.85. Okay, that 0.85 was given to us in the problem. 14 we solved for up here from our weight. Okay, we know that equals Fx, which we solved to be 21.1, minus our force of friction. Okay, so we take 14 times 0.85. Then how do we get 21.1 on the other side? Which one? Yeah, how do we get it to the other side? Subtract it. Okay, so 14 times 0.85 is what? 11.9 equals 21.1 minus force of friction. We want to subtract over 21.1. Good. So that gives us negative 9.2 equals negative force of friction. Okay, so we can just cancel those negatives out. Force of friction equals 9.2. Does that part make sense? Okay. So then we know that force of friction equals 9.2. Now we can go back to our force of friction equation and substitute in mu k times normal force equals 9.2. We substitute normal force in. We solve that to be 91.7. And we're going to divide which of those two?
9.2 divided by 91.7.
Exactly. We're going to move over the 91.7.
I got 0.1003.
Okay. 0.1003. Is that what you said?
Yep.
Yeah, so you can just round that to 0.1. Okay, 0.10. Pretty much, you can round to 2 decimal places. That can be the plan, 2 decimal places. Okay. Okay, so this one you can do on your own. It says a crate weighs 1,000 newtons, slides down incline at 0.41 meters per second squared. If the incline sits at 26 degrees, what is UK? So you're solving for coefficient. I think I gave you everything that you need to go ahead and do it by yourself. Okay, so everyone, what'd you get for your mu k? 0.44.
For both rounds.
Good, good. All right, good.